An insect is sitting on a branch 3 meters above the water. It doesn't see the fish below. The fish sees it. The fish calculates the angle, accounts for the fact that light bends when it passes from water into air, which means the insect isn't actually where it appears to be, adjusts, fires. The insect doesn't finish the thought it was having. My name is Detective Honey, and this fish just did physics, with a brain the size of a pea. Let me establish what we're dealing with. The archerfish lives in the brackish mangrove waters of South and Southeast Asia, Indonesia, Thailand, Australia. It grows to about 30 centimeters. Unremarkable to look at, it hunts insects and small animals sitting on branches and leaves above the water. It does this by spitting, a precisely aimed jet of water, up to 3 meters. That part is well known. Here's the part that is less well known. To hit a target above the water, the archerfish must account for light refraction, the bending of light as it passes from water into air. This bending makes the insect appear to be in a different position than it actually is. The archerfish corrects for this every single time, automatically, with a brain the size of a pea. I want to be clear about what that means. This fish solves a physics problem that took humans centuries to formally describe before it has breakfast. Here's what the research says. Scientists at the University of Bayreuth in Germany published studies documenting that archerfish don't just aim at where the insect appears to be. They aim at where it actually is, accounting for refraction, accounting for distance, accounting for the angle of their shot, all simultaneously. The research also documented something else. Young archerfish miss, frequently, but they watch, they observe other fish, they adjust their technique, and they improve, demonstrably, over time. Scientists studying this learning process found it relevant to understanding how complex calculations can be performed by minimal neural architecture. In other words, how something so small can learn to do something so precise. That question turns out to be extremely interesting to researchers studying neural efficiency. Now, the Pokémon connection. In 1996, Nintendo released Pokémon. One of the original 151 was Squirtle, a water type that fires precise jets of water as its primary attack. The water gun move, later hydro pump. The design team drew from real aquatic animals when creating water-type mechanics. The archerfish, a real animal that fires precise jets of water to hit targets above the surface, is the closest thing in nature to what Squirtle does. Squirtle is currently fictional. The archerfish has been doing this for millions of years, in mangrove swamps. So, what do we make of the archerfish? 30 centimeters long, accounts for light refraction before every shot, learns and improves through observation, has been doing this in Southeast Asian mangroves for millions of years. Inspired, at least in spirit, one of the most recognizable Pokémon ever designed. It doesn't know about Pokémon. It doesn't know about physics. It doesn't know about the University of Bayreuth. It knows about insects and angles and the precise amount of water required to end a particular insect's afternoon. I've been a detective for a long time. This is the most casually competent suspect I've ever filed a report on. It's not trying. That's the part that gets me. It's just having lunch. Case closed. Detective Honey signing off. The archerfish was not available for comment. Next case in the stoat. It hypnotizes prey by dancing. This has been filmed multiple times. The prey watches. It gets closer. Then the stoat stops dancing. Case number 019. Opening soon.